Hi everyone, let's have a lesson today on seafloor spreading. Before we get started, let's have an interview of our learning objectives. By the end of our lesson, you will be able to first, explain how seafloor spreading occurs, second, describe the structure and evolution of ocean basins, and lastly, understand how seafloor spreading contributes to the movement of tectonic plates and the formation of geological features on Earth. Okay, put that aside for now, and let's consider the theory of seafloor spreading.
So now, let's go to seafloor spreading and paleomagnetism. Harry Hess, a geologist and oceanographer, Robert Dietz, proposed the theory of seafloor spreading. He proposed that new oceanic crust material was formed at mid-ocean ridge. The new material then spreads outwards because new materials continues to rise from beneath the Earth's surface. Paleomagnetism is one of the foremost evidence for this theory. Because basaltic lava contains iron-bearing minerals, these minerals act something like tiny compasses, freezing in the orientation of the Earth's magnetic field into the rocks as they cool and solidify. Over Earth's history, the magnetic field has reversed, and so a banding pattern of normal and reverse magnetic polarity has built up on the seafloor sides of the mid-ocean ridge, which would tend to favor the argument that new crust is being formed at the ridge and being pushed outward.
Now, let's take a closer look at how seafloor spreading actually works. At mid-ocean ridges, molten rock or magma rises up from the mantle and forms new oceanic crust. As more magma rises and cools, it pushes the older crust away from the ridge, and that causes the ocean floor to spread. This continuous process adds new material to the ocean floor, but don't worry, the Earth isn't getting larger. That's because older oceanic crust eventually gets abducted back into the mantle at deep sea trenches where it's melted and recycled into the Earth's interior. Let's dive deeper into the process of seafloor spreading. It all starts at the mid-ocean ridges, which are essentially underwater mountain ranges where the Earth tectonic plates are pulling apart. Deep beneath the surface, magma from the mantle is pushed upward through cracks in the Earth's crust, driven by convection currents in the mantle convection. As the magma reaches the ridge, it erupts and begins to cool rapidly when it comes contact with cold sea water. This cooling process causes the new magma to solidify into new oceanic crust, which forms a new narrow strip right along the ridge. Over time, more magma continues to rise and push through, causing this new crust to expand outward. Now, as new crusts form, the existing crust on either side of the ridge is slowly pushed away. This movement is quite slow, usually at a rate of few centimeters per year, but over millions of years, it adds up to significant distance. The movement is called seafloor spreading. Eventually, the oceanic crust is denser than continental crust, drifts to the edge of tectonic plates. At this edge, it reaches areas called subduction zone, which are often located in deep sea trenches. Here the older oceanic crust is forced downward beneath a lighter tectonic plate in the process known as subduction. As the crust descends deeper into the mantle, it gets subducted to intense heat and pressure, causing it to melt and disintegrate back into molten rock. This material is then recycled into mantle and it may eventually become part of the magma that rises at mid-ocean ridges again, completing the cycle.
Features of ocean floor. Seafloor spreading also shapes many of the ocean floor features. In fact, the mid-ocean ridge itself is the largest mountain range in the world, extending over thousands of kilometers. Next to it, we also have the ocean trenches, the seamounts, and the volcanic islands. We also have smokers, which are high-temperature geothermal vents where superheated water is released near this ridge.
Each of these features is caused by the movement of tectonic plates driven by seafloor spreading and forces beneath the Earth's surface.
Now let's go to transform faults and mid-ocean ridges. Now let's talk about transform faults. These are areas where the mid-ocean ridge is divided into sections. Along these faults, the sections of the ridge literally slide past each other, creating room for the movement of tectonic plates. Transform faults play as an important role in accommodating the spreading process and keep the tectonic plates moving in different directions.
So now, let's go to the review and the concluding of our topic. Let's quickly review what we've learned today. Seafloor spreading occurs at mid-ocean ridges, where new oceanic crust forms as magma rises from below the Earth's surface. As this crust cools, it records the direction of the Earth's magnetic field, leading to the formation of alternating magnetic stripes. The ocean floor spreads out as new crust is added, and older crust is abducted at ocean trenches, maintaining a balance in the Earth's size.
Seafloor spreading has shaped the ocean floor, creating features ranging from ridges, trenches, and seamounts to transform faults. This is one of the key parts of plate tectonics that tells us how our surface is constantly changing.
That's all for the lesson today. You now understand what I mean when I talk about seafloor spreading and how it affects the surface of the earth. Till we meet again, continue to discovering the beauties of our dynamic globe.